Hey everyone, welcome back to The Explainer. Today, we are taking on humanity's absolute oldest desire. Since the dawn of civilization, we've looked at the stars, we've read tea leaves, and more recently, we've built massive statistical models, all just to answer one fundamental question: what happens next? Predicting the future has literally always been the ultimate superpower. But is it finally achievable? Well, today we are going to look at the groundbreaking research and data showing how modern technology is turning that mythical crystal ball into a quantifiable, operational reality.
So, can AI actually predict the future? For decades, traditional forecasting has been exactly that, a flawed crystal ball. Standard analytical procedures rely heavily on historical metrics, just to give us a single-point estimate. And sure, that's fine for perfectly stable conditions. But what happens when there's an unprecedented market shift, a global supply chain blockage, or human emotion gets thrown into the mix? The old models completely break down. But as we're going to see today, the convergence of predictive analytics, generative AI, and game theory is changing absolutely everything. We are moving away from just guessing what might happen to running dynamic simulations of what will happen.
Okay, let's dive into this structured roadmap for today. We're covering 1. The new crystal ball. 2. Beyond the black box. 3. Forecasting the stock market. 4. Predicting scientific breakthroughs. 5. The edge AI revolution. And finally 6. The future of forecasting. Let's get right into it.
Starting with Section 1, the new crystal ball, where we move from flawed forecasts to dynamic simulations. To quickly set the stage here, it's really important to understand that standard analytical procedures constantly struggle with unprecedented market shifts simply because they lack contextual intelligence.
Which brings us directly to Section 2, Beyond the Black Box. This is where generative AI and synthetic data come in as the ultimate solution to that historical rigidity. To really understand where we're going, we have to look at why the old models fell short. Traditional predictive models laid a super solid groundwork, but they were essentially a black box. You'd have these complex neural layers spitting out highly accurate predictions, but they couldn't explain their underlying reasoning to an actual human executive. As you can see right here, the old way was totally rigid, but the new way, powered by generative tools, fixes this by translating raw mathematical feature weights and numerical correlations into plain, natural language. It's a real game changer because business users can now literally have a conversation with their forecasting models, asking why a specific forecast was generated and getting an immediate, explainable answer. Behind the scenes, one of the absolute biggest hurdles in predicting the future is data sparsity, especially for rare black swan events where we just don't have historical data to draw from. To fix this, generative adversarial networks, or GANs, and large language models step in to create synthetic data. Basically, they learn the statistical properties of real-world data and generate diverse, synthetic records to simulate complex variations without compromising any privacy. This allows the algorithms to run thousands of complex what-if scenarios in minutes. And by translating all of this output into universally understandable language, generative AI seamlessly bridges the gap between operations on the ground and leadership in the boardroom.
Moving on to Section 3, Forecasting the stock market. This is where machine learning totally meets game theory.
Let's apply what we've learned to one of the most notoriously difficult environments to predict on Earth: finance. We are seeing a massive shift right now because AI models are outsmarting traditional stock market predictions by simulating human behavior through game theory. As defined here, game theory is a strategic framework that models interactions between decision-makers in competitive environments. Think about it for a second. The stock market isn't just numbers on a screen, right? It's a massive, multiplayer game driven by risk tolerance, emotional biases, and herd behavior. Game theory brings incredible insights into investor psychology and concepts like the Nash equilibrium, which helps us understand stable conditions where investors' strategies are balanced, straight into environments that used to be dominated by basic statistical models.
The key takeaway from this quote is that game theory provides a really powerful framework for understanding those strategic interactions. While machine learning excels at processing massive data sets super fast to uncover subtle historical patterns, game theory steps in to predict how human beings will strategically react to that exact same data. It's really the perfect marriage.
So, the crucial point is that modern financial forecasting requires a three-pronged approach. You have machine learning doing the heavy lifting on pattern recognition. Then you have natural language processing running sentiment analysis on social media and news reports to gauge the market's mood. And finally, you have game theory predicting the strategic decision-making and competitive dynamics. Integrating these three elements creates a highly accurate, dynamic simulation of financial markets that accounts for both the cold, hard math and the unpredictable human mind. Let's jump to Section 4, Predicting Scientific Breakthroughs, LMMs versus Experts.
We're moving from the trading floor straight into the laboratory here. If AI can predict market movements, can it actually predict the outcome of human discovery? The mind-bending reality is, yes, absolutely. AI is now accurately forecasting the results of scientific research before the experiments even happen. Just look at this number, 0.89. In a recent crowdsourced study testing whether large language models could predict the empirical findings of a complex behavioral science experiment, GPT-4 achieved a correlation of 0.89 between its aggregated forecasts and the realized effect sizes. To put that into perspective, a cohort of 119 human experts scored a 0.87. GPT-4 literally outperformed a massive team of human specialists. And just to show you how fast this is moving, GPT 3.5 only scored 0.07, showing just how rapidly this predictive reasoning is evolving.
And this brilliantly illustrates that it isn't just a fluke in behavioral science. When stress-tested against human experts on predicting empirical AI research, a system combining a fine-tuned GPT-4 with a paper retrieval agent predicted which research ideas would perform better with an accuracy of 64.4%. The human expert majority? They only reached 48.9%. The AI decisively beat human experts in predicting what new technological ideas would actually work in the real world. This has massive implications for allocating scientific resources efficiently and avoiding super costly dead ends. All right, Section 5, the Edge AI Revolution, Action in Real Time. It is one thing to run a massive predictive model in a cloud data center. It's a whole other thing to make those predictions actionable in the real world instantly. That requires taking the processing away from the cloud and putting it directly onto the devices themselves. And the scale of this hardware evolution is staggering. The global AI chips market for edge devices is projected to exceed $80 billion by 2036. This includes specialized AI accelerators, neural processing units, and edge-optimized algorithms that maintain energy efficiency while delivering massive compute power. This whole hardware shift is the physical foundation that makes real-time future prediction totally possible. This hardware shift naturally builds into a super practical closed-loop process. Because the AI chip is directly on the edge device, like a sensor on a factory machine or inside the intelligent cockpit of an autonomous vehicle, we get Step 1, local data capture. Instantly, we move to Step 2, real-time prediction. By running machine learning locally, the system can predict a mechanical failure before it happens or anticipate a pedestrian's movement. And finally, Step 3, autonomous action. It acts on that prediction instantly without waiting for data to travel to a cloud server and back. It yields a massive increase in safety and efficiency because cloud latency is entirely eliminated.
Which brings us to our climax today. Section 6, the future of forecasting, agentic systems. So where is all of this going? We have AI that can simulate black swan events, predict the stock market, forecast scientific breakthroughs, and process it all instantly on edge devices. The ultimate climax of this technological convergence is agentic systems. According to industry forecasts, by 2026, agentic AI will make the massive leap from an experimental technology to an operational reality. We are entering an era where AI systems don't just passively predict the future and wait around for a human to read a report. Instead, edge resident agents will autonomously make local decisions. They will inspect, adjust, and remediate systems in near real time based entirely on their own predictions. Humans are going to shift from being the operators to basically being the guardrail.
Which leaves us with this final, profound question. Predictive AI is rapidly moving from a clunky, historical black box to a dynamic, conversational, and completely autonomous crystal ball. It is actively reshaping finance, science, and global infrastructure. So, what would you do if you could accurately predict the outcomes of your own decisions? How will this level of foresight reshape your industry, your career, or just your daily life? The tools to see tomorrow are literally being built today. The only question is, how are you going to use them? Thanks so much for joining me on this explainer, and keep questioning the future.